3.3, number 134. So we have a function f of x equals 1 on x minus x squared. It says a equals 1. I want to find f prime of a. So part A is find f prime at a. The second part B I'm not going to do because in the textbook this has a t next to the problem, and that means it's some sort of technology problem, and when it says graph f of x and the tangent line, it means in a calculator, it doesn't mean by hand. This is probably too complicated of a function for us to graph by hand at this point in the course. Certainly we'll know how to do this later by the time chapter 4 is over, but right now that is not their expectation. So B would just be done in a calculator. So I'll compute this and the tangent line, right? I'll also find tangent line equation so that you can graph that in a calculator. And they want you to see some sort of pictorial representation of the tangent line and the function together. So we need to find f prime of a, so I'm looking for f prime of x at first. I'll plug in 1 in a second. So f prime of x should be what? Well, I'm going to view 1 on x, right? I'm going to view this as being x to the negative first, of course, so I can use a power rule on it. So using the power rule on it, negative 1 comes down. I leave x untouched, but its power changes to a negative 2, and then using a power rule on x squared, I also have a negative 2x here. Okay. Rewriting this without negative exponents, I'll have negative 1 on x squared minus 2x. I want to know what the value of this is at 1, i.e. the slope of the function at 1 will be given by this number we'll have in a second. So the 1 squared minus 2 times 1 looks like negative 1 minus 2 is negative 3. All right, so the slope is negative 3. We have finished part A as it's written in the textbook. We'll go ahead and get the tangent line equation as well. So again, for the tangent line, we have its slope already. So y equals negative 3x plus b. I need a point xy that the tangent line possesses to solve for b. So the x value is, of course, the a value of 1 here. I do not have yet the corresponding function value that's on this line, but it's the same one that's on this function because that's a point of intersection between the curve and the tangent line. So if I would just plug this x value into the original function, right, f of 1 itself should be 1 over 1 minus 1 squared, but that's 0, of course. So it looks like 1 comma 0 is on the tangent line. 1, 0 is on the tangent line. So therefore, we can put 0 equals negative 3 times 1 plus b, therefore b is positive 3, and we have our tangent line completed. Y equals negative 3x plus 3.